section that you want to go off and edit. And as Joe was saying, video editing is a great example because there's multiple stages. First, you have to decode the video that you want to work with. And then you have to use a bunch of compute power to go in and clean up and add effects and everything that you want to do to change your video. You have to render that back so you can see it. And then you have to ultimately encode that thing or push it. You can see on the bottom whether it's YouTube, Facebook, or some other format so you can enjoy it or share it with your friends and family. Later on in the presentation, John Taylor is going to give you some very quantified details about how we can accelerate all of these steps. For the purpose of this demonstration, just want to show you the actual compute piece of things. So we've got a video here, and up in the top, you can see there's a frame rate. It says 30 frames a second. It's not moving, and GPU is off. So what we're going to do is run all of the performance algorithms on just the x86. So we'll go ahead and start it up. On the screen, the left-hand side is the original video. The right-hand side is cleaned up. And if you pull up the performance monitor, this is AMD System Monitor. It's a task manager, but unlike the one that comes with Windows, we actually show you what the GPU is doing. And you can see it's taking our quad-core, this is running on an A10 Trinity platform. It's taking the quad-core x86 and it's pegging it. So it's using a tremendous amount of compute, and you see you're getting about 8 or 9 frames a second. It's doing a lot of work to clean this video up so then you can go off and share it with your friends and family. But now we're going to go off and change. You see we're going to hit the shortcut key to turn GPU on. And what we've done here, we'll run the same algorithm, but using the OpenCL programming environment, we're now going to run this thing on both x86 and GPU. So you'll see your frame rate just jumped up by a factor of 4. So now as an end user, as you sit there and apply these effects, you can immediately see what it's doing to your video. You don't have to wait for it to slideshow along and look at it 20 minutes later. When you pull up the system monitor, what you'll see now is the CPU is still doing a hefty amount of work because it's heterogeneous computing, but the GPU, those SIMDs, hundreds of GPU cores are doing this processing. And so the effect is overall system power is lower, that's one. The system is now more responsive. If you have queued up a number of your home videos and you say, okay, start this off, and now I want to go surf the web or do email, the prior example on just using x86, your system is pegged. You can't do anything else. So this opens up the ability to go do other things with your system. So this is a compounding effect of better performance at lower power, giving your system the ability to go off and do other things. And so now the ISVs say, hey, I can go put even more powerful algorithms in here. I can give people better experiences and more effects, but I can do it on a mainstream system and give them the experience they want to. So we think this is a great example of, again, using all those pieces of it, and you'll see some more data later to help quantify this.